Well, good afternoon and welcome to this last panel, which deals with engineering education and global mobility. My name is Claude Laguë. I'm the Dean of the Faculty of Engineering at the University of Ottawa. I'm also the past chair of the National Council of Deans of Engineering and Applied Science as of, I guess, a month and a half or 2 months ago, almost. And NCDES is an organization basically where all the institutions across the country that provide accredited undergraduate engineering programs are member of. So there's 42 member schools among our organization. I want to, of course, welcome all of you who are here this afternoon, and thank you also for your resilience. Being in universities, we know that Friday afternoon classes are never very popular. So I think it's a credit to you that you've made it until the end of the afternoon, and we will try to proceed as rapidly as possible. My colleagues and I want to thank the Ontario Centre for Engineering and Public Policy for organizing this panel discussion on engineering education and global mobility, and also for inviting the three of us, which I will introduce in a few minutes, my two colleagues, to participate in this very important discussion. So the two other panel members this afternoon are Ms. Jacinta O'Brien, who is the current chair of the Canadian Engineering Accreditation Board and also a principal at Strategic Alternatives in Toronto. And also my colleague at my far left, your far right, Dr. Anthony Vannelli, who is the Dean of the College of Physical and Engineering Science at the University of Guelph. And of course, he, like me, is a member of NCDES, and in fact, he is right now the chair of the Education Committee at the National Council of Deans of Engineering and Applied Science, and he will be, from that perspective, able to provide valuable insight into where we're heading with engineering education and global mobility in Canada. So we will try to proceed as rapidly as possible. Kim had promised earlier that the target was to be done by 4 o'clock. I'm not sure if we're going to be able to make it, but we're going to make sure that we don't go past 4 o'clock by too much. So my introductory remarks are going to be very brief. Our panel deals with what I consider to be two complementary issues, engineering education and global mobility. And when you look at engineering education, basically, and within the scope of our professional system, basically engineering education is the first formal step towards becoming a licensed professional engineer. So the main role of our engineering education system is basically to provide the engineers of tomorrow with the solid knowledge and also the skills that they will need and that they will need to further develop during the course of their professional careers to address a number of issues that have been presented earlier today. So the theme of this conference is to engineer a better Ontario. So of course we need to equip our graduates with the knowledge and skills that are required to do that. And I would also argue that this goes well beyond Ontario. Our engineering students, our engineering graduates, will be expected to practice engineering probably beyond the borders of Ontario, beyond the borders of Canada, probably at the global level. We're all operating in a global environment right now. And in fact, this was the theme of Engineers Canada workshop that was held yesterday on the globalization of engineering. And one thing that I took back from that workshop is the fact that Canada ranks either third or fourth in terms of export of engineering services. So I think because of that, we have a responsibility in our engineering schools to prepare our students, to prepare our future engineers for that reality. We also need to educate our engineering students so that they will be able to influence innovation and public policy decisions. We heard from Dr. Patry about this morning. And we also need more and more to prepare them to be able to get their message across to the public and to the government. And I think the presentation we had from Mr. Newman this morning also strongly address those important issues. The need to have more engineers in elected positions definitely is something that we all feel, I think we all believe is important, and it's something that we need to find ways to incorporate into our programs of study to develop those skills among our students. And finally, we must also always remember that one of the very important functions of our engineering education system is to make sure that our graduates will contribute to the safety, well-being, and quality of life of individuals and societies. So when you look at all of that, in many ways, the ideal foundation that that we are asking our engineering education system to provide, this foundation is becoming much broader and much more diverse than it was 10, 20, or 30 years ago. And engineering education programs are evolving to address those growing needs. When I look at the other theme, global mobility, to me as a dean and as an engineering educator, it speaks to the need to deliver educational programs that will provide our students with the latest development in engineering knowledge and skills at the global level so that they're aware of the reality of engineering all over the world. And also that will provide them with the knowledge and skills that will enable them to practice engineering here and abroad as part of multidisciplinary and international project teams, which is rapidly becoming a standard. One thing that we can say is that in Canadian engineering schools, we typically provide students with a learning environment that is among the most international on university campuses. We have typically engineering schools, that's where you will find the largest proportion of international students. If you look at the latest national data, it's about 12% of our undergraduate students who are not Canadian citizens or permanent residents, and it's over 35% of our graduate students who are not Canadian citizens. The other characteristic of our faculties and colleges of engineering is that we have also a very international faculty member complement. Our professors bring a lot of international experience and expertise to the classroom and to the lab. When I look just at my own faculty at the University of Ottawa, and I look at where our professors have either lived or studied, well, you find countries like China, Egypt, France, Germany, Greece, India, Iran, Italy, Japan, Poland, Romania, Russia, Serbia, South Africa, Switzerland, Turkey, the UK, the Ukraine, and the USA. And that's a faculty that has about 115 professors. So because of that, and you will find that all over the country. So I think that's another component that we have in our schools that provide this international perspective to our students. Each year, Engineers Canada publish a report that's titled Canadian Engineers for Tomorrow, and each year they have a different theme in terms of specific issue that they are looking a little bit more in details. And in 2008, they did a survey of Canadian engineering schools on exchange study programs. And they found that 20 institutions reported that they are participating to various degrees in student exchange programs, sending Canadian engineering students to abroad for part of their programs of study. And they reported more than 45 different countries as destinations for those students. However, and I'm sure that my colleagues will elaborate further on that, there's a lot more work that needs to be done to further promote and facilitate study abroad experiences for our Canadian engineering students, and especially at the undergraduate level. When you look at, for example, the school year calendars around the world, well, they don't always match the Canadian school year calendar. So that's definitely an issue for students, especially students who want to leave for less than a year. When your semesters are not matching, that creates, of course, an impediment for this international mobility. There's also the issue of addressing course equivalency issues, so making sure that the courses that the students are taking at foreign institutions are equivalent to what is required at the Canadian home institutions for the awarding of the degrees. The lack of or the disconnect within the school years across the world sometimes may have negative impact on the duration of programs of study. So students who will choose to go abroad may suffer a delay in their programs of study. And it can also have negative impact in terms of summer or co-op employment. For example, in many countries in Europe, the school year will end in June. So the students coming back, instead of having 4 months for a summer job, if their school year start again in September in Canada, they will only have 2 months. And that can be a problem for many students. And finally, in terms of things that we need to address, there are also the issues that are related to accreditation. There are regulations that are associated to exchange study and transfer credits that we need to take into account. There's also licensure expectations and requirements for faculty members teaching courses in engineering science and engineering design, and for which, when those courses are taken at foreign institutions, we need to make sure that those credentials requirements are met. But I think it's all problems that can be resolved. After all, we're all engineers, and that we're actively working on to further facilitate this international mobility of our students. So I will stop here at this time, and I will invite my two colleagues, starting with Jacinta, to address those two issues of engineering education and global mobility from their own perspective of the Canadian Engineering Accreditation Board, and then from another dean of engineering educator. So two different perspectives on these issues. Thank you.
Thank you very much, Claude, and I will reiterate Claude's comments. Thank you very much for your resilience. We're the last panel on. We'll try to make it quick. And as Claude indicated, we're going to be talking about engineering education, and I'm talking about it from an accreditation perspective. Many of you in the room today will have graduated with a Canadian engineering degree, and what I'm going to start by doing is telling you why it's so highly regarded. And to do that, I'm going to start by talking about the Canadian Engineering Accreditation Board. 15-member board under the auspices of Engineers Canada, comprised of all licensed engineers representing across Canada and all disciplines, or to the extent that you can get all disciplines in 15 individuals. The board was created in 1965 with a mandate of providing a service across Canada. And the goals of the Accreditation Board are principally to identify those programs to the regulators that meet specific high standards, standards that could be considered appropriate for the formation of an engineer that can enter professional practice. Additionally, we're looking at engineering education with a viewpoint to its continuous improvement, and we also have the mandate of advising the Engineers Canada Board of Directors on international matters related to both engineering education and accreditation. So as I said, our main goal is the accreditation of engineering programs, and we do this in what I would consider a very cost-effective and efficient way. We provide this service not only to Professional Engineers Ontario, but to all regulators across Canada, with the result that graduates from CEAB accredited engineering programs are considered to have met the academic requirements for licensure as professional engineers. And because we have a uniform standard across Canada, that means that students, whether you've graduated from the University of Ottawa or the University of Guelph, can apply to become licensed in British Columbia, for example. So we've got mobility across Canada. From the Accreditation Board's perspective, there are two issues, or two ways to look at internationalization, or what's happening globally. First of all, internationalization of Canadian education, and secondly, global mobility for our own engineering students. With respect to internationalization, what the Accreditation Board has been seeing, and more frequently, are agreements between Canadian and non-Canadian higher education institutions. So universities enter into agreements between a Canadian university and an offshore university to allow exchanges between their students. There are also formal exchange programs where, for example, in Quebec, Quebec University may enter into an agreement where some portion of the Quebec students' undergraduate degree is taken in France, for example, and that's integrated into their program. And lastly, what we've seen most recently has been the establishment of satellite campuses. The classic example currently is the University of Waterloo, which has established a satellite campus in Dubai. So this can only increase in both number and type of international experiences. How we address these international experiences is through what we have, and that is credit regulations. These were initially adopted in 1995, actually to address issues that were happening internally, and that was students from non-engineering programs who wanted to have a pathway to take an engineering program and have their previous coursework, previous academic formation recognized in some way, and also students who had taken a technology program looking for a pathway to move into the engineering programs. With the increasing focus and desire to open the undergraduate programs to a more international experience for our students, what the Accreditation Board has been doing most recently is looking at how our regulations could become clearer and provide more accommodation for international experiences. The impetus for this are the so-called, what we call bridging programs that would allow a bridge between, for example, a technology program and an undergraduate program, engineering program, and also in order to facilitate international, transnational dual degree programs between Canadian universities and offshore universities. While we're looking at these credit regulations, the main issue for the board is to maintain the very high quality of the educational experience that graduates are getting and ensure that the formation that the students have coming out of programs that have an international component to them will still comply with the Accreditation Board's criteria. And the guiding principles that we are using while we're looking at revising these regulations are, first of all, to make sure that the way that we treat our own universities versus how we treat offshore universities, there is equitable treatment. We're not holding either one to a higher or lower standard. Secondly, we want to make sure that there's ownership of the degree by the degree granting institution so that the regulators in Canada can have confidence that when the graduate from a program at University of Ottawa applies to become a licensed engineer in Ontario and they've had an international experience, that truly complies with the accreditation criteria, and the University of Ottawa has taken ownership of that program. And finally, we're also looking at what the board itself needs to do to assure the regulators and ourselves that the academic formation of students with international components is still at the very high quality and standard that we have for our own domestic programs. Switching over to global mobility for undergraduate students, how this is achieved is principally through what we call mutual recognition agreements. And what these agreements are between Engineers Canada and another signatory jurisdiction, and the purpose of the agreement is to recognize the equivalence of the systems that are used to accredit engineering programs, and also to recognize that the graduates coming out of these accredited programs are substantially equivalent. We have a long-standing mutual recognition agreement with the organization in the U.S. that accredits undergraduate programs. That's ABET, which is, I guess, the shortened form for the Accreditation Board for Engineering and Technology in the U.S. But what I'd really like to do is focus on the Washington Accord, which is one of 6 international agreements that Engineers Canada has entered into. There are 3 agreements that focus on education and 3 agreements that focus on professional practice. And the one that deals specifically with undergraduate engineering education is the Washington Accord. Originally signed in 1989 by 6 signatories, and Canada was a founding signatory. We have since moved to 13 full signatories, the latest of which was Malaysia, and they became a full signatory in 2009. And we also have a number of what we call provisional signatories, and these are jurisdictions who are preparing themselves to become full signatories, meaning that they are preparing their accreditation systems to be demonstrated as substantially equivalent to our own. In the same way that the Accreditation Board visits and audits and assesses and evaluates engineering programs for the purpose of determining accreditation status, so too do the Washington Accord signatories evaluate each other's systems. So, appreciating the fact that Engineers Canada realized that the Accreditation Board system would be evaluated in 2009, the Accreditation Board, in conjunction with the deans, the National Council of Deans of Engineering and Applied Science, and with the regulators themselves, took a look at our criteria and our procedures and identified the need to move toward an outcomes-based assessment. So what we did was we incorporated what we call graduate attributes into the accreditation system so that we could more closely align with our Washington Accord signatory partners, and also take another look at how we evaluate the engineering graduates that are coming out of our programs. What happened then was we developed the criteria after consultation. It was approved by the Engineers Canada Board of Directors in 2008, and when we were evaluated by the Washington Accord in 2009, we were unanimously endorsed as having systems and graduates that were substantially equivalent to all of the other signatories. What this means is that graduates from Canadian undergraduate engineering programs would be considered to be equivalent to students that graduate from engineering programs in, and I can go back to the lists of the 13, so the US, England, Ireland, Australia, New Zealand, Malaysia, Singapore, Chinese Taipei, Hong Kong, Japan, Korea, and correct me if I've missed any. So there's quite a list, and it's growing. And that's one of the 3 issues that I'd like to bring up is the growth in the desire worldwide to reach the Washington Accord standard and the desire of the Washington Accord signatories themselves to encompass more than simply the, let's call them the Commonwealth plus the US plus some parts of Asia. So there's a focus now to see how we can, I guess, attract jurisdictions from Europe, from South America, and from the Middle East. In addition to that, in Europe, and this could be a whole other discussion, which I won't get into in a lot of detail, there's something called the Bologna Declaration, and that was an agreement among, I believe, ministers of education in Europe to move to a cycled degree model for post-secondary education. So moving away from the structure that they had previously, what they've done is move toward adopting a bachelor, master, PhD model, which is similar to what we are already using in Canada. But there's differences, many differences. Language is one of them, structural differences. So there's a need for us to look at how we can best integrate with the Bologna Declaration countries, with European countries. And finally, there's also an opportunity to further strengthen internationalization and mobility by developing relationships with what we could call kindred organizations, such as the World Federation of Engineering Organizations, simply for the betterment of the profession overall. And with that, I'll hand it over to Dean Vannelli.
Thank you, Jacinta. This reminds me when I gave my first talk when I was a PhD, it was in Florida, it was at the end of the day, and I had an audience sitting of 2 waiters and 3 guys with a martini, so I'm glad you're all here, so that's great. I'm not going to be using any slides. I just want to talk and follow up what really Claude and Jacinta set up and really complement their discussion in a slightly different direction. I'm going to be talking about 3 points. I want to talk about what Jacinta and Claude had mentioned with the curricula development and the program accreditation and its link to the mobility that was discussed. The innovation in the curricula that's actually occurring in Canada and worldwide in this engineering education. And I want to end off with some food for thought. And this was really discussed throughout the day, is some of the structural challenges we're dealing with, obviously coming out of engineering education, and opportunities to resolve many of the problems we actually talked about throughout the day. Innovation, our competitiveness, lack of engineers in the water area, the electrical area, the emerging infrastructure challenges that this country, actually the world, is facing. And where do we find these young men and women to replace the aging population in many of those sectors? It's a big, big problem. In the curricula that we're looking at, as Jacinta has talked and Claude, what's happening that I think is great news is in some ways, I think the synchronization or equivalence that's really being talked about of an engineering degree. So if you receive your engineering degree, whether it's in Canada, the United States, we have some challenges in Europe, but that can be worked out, I believe, in Asia, that the engineer is then literally free to move, having that passport, engineering passport, as well as the other passport to come in the country and work, and vice versa. So that mobility is built in, and with the synchronization and the extended work that we're doing, and that's been going on for many years and will continue, this will be making this transition much easier. So the mobility is happening, has happened, and will continue to happen. Canadian engineering in particular, in the last few years, certainly my role as the chair of the Education Committee, along with Claude previously as the chair of the NCDAS, the deans, along with Jacinta as CAB, have been working together hand in hand with a great enhancement into our accreditation process, which is the graduate attributes assessment that we're now working at, as well as our normal accreditation process that many of you are familiar with, the credit-based process. This is allowing us to look at our curricula in more innovative ways, to monitor our curricula in Canada and these schools that are accredited, and to enhance them. And that's good for our students and also for the visitors that are coming into Canada to watch what's happening with our programs. This is exciting times as we're going through this, and this is again synchronizing with some of the activities certainly that have existed in the United States with their engineering programs and across the world. Outcomes measurements, and seeing the impact of our education is important, and assuring the quality, which Canadian schools take a lot of pride in. The innovation in the curricula, and especially with internationalization and mobility, if I can use those terms interchangeably, will be a hot button over the next few years. I think it's very clear that many of our students, let's start there, really would like to come into this discipline, come into our programs, because they want to be mobile. We have programs like Engineers Without Borders that many of us share and take a lot of pride in because of what they do. They capture a very captive audience and students that want to be mobile, want to practice their profession, and bottom line, they want to make a difference. They want to make a difference to the future. And they want to do that with pride, being Canadians, and vice versa with others coming and working within our country. There's some big challenges before us, and this really is the main point I want to focus on and to conclude today with this talk. A few weeks ago, I had the pleasure of meeting the president of a technical university in Ghana that is trying to build the university. And he came with an engineering problem. He said, well, in September, we're setting up this school, and I need 450 faculty to teach these engineering programs. And I said, man, have you got a problem. It was not an easy discussion. He was going across in Canada, Australia, New Zealand, the UK, basically English-speaking countries, United States, to find, work with the deans, whoever he could find, to certainly try to solve this problem. But it was interesting in talking to him. I said, why did you choose to come to Canada specifically? He said, because I believe Canada has always chosen to make a difference in our education process, and they have. And we have students that receive their doctorate from this country that we take a lot of pride in, and that's why we're here. And this raises one of the interesting challenges we're going to have before us. The line between domestic and international students, engineering students, will blur over the years to come. And I don't want to use any political terms like globalization or anything. It's not about that. It's the fact of free movement of an occupation, of engineering, which is occurring and has always occurred. The lines are blurred, and they will continue to be that. Yet in Canada, sometimes, I think, and even in our own province, we draw the line. We differentiate between domestic and international graduate students and the funding levels that they should achieve or receive compared to domestic students. And I understand that as a taxpayer, and I understand the political argument. But do a quick back-of-the-envelope calculation. Let's take a PhD student. If Ontario increased and gave full funding to 1,000 PhD students from all over the world, the very best that would choose to come here, and they'll come to Canada, because they have a lot of problems getting visas in some other countries because they're at war with them. They'll come to Canada. They want to be at Canada, many of our faculty in our universities. That might be a $30 million investment, steady state. Those 1,000 students, deans can attest to this, and many of you that run companies can attest to this. They stay in Canada. They want to stay in this country. Guess what? They become high-paying taxpayers. You get that money back. Those students are also involved in IP development, many with the faculty we heard today and with some of the others, both in government agencies, et cetera. We get that money back tenfold, morefold. And I think that's the missing issue that we have to challenge ourselves. If policy is going to change on engineering education, is that this line between domestic and international students will be blurring and has to blur to the point that we take pride in the students that we bring into our system. As Claude has said, many of our graduate programs in Ontario and Canada, engineering accredited programs, 35% or even higher are international students. Let's go further. In the United States, and some of you know this quite well, if you're a student at MIT or Berkeley or Stanford, it's closer to 95%. It's very difficult to attract the American students to do graduate work. And guess what? They set up Silicon Valley. They've stuck around. They've helped to build that country to a different level. I think that's the strategic thinking this brings to us. That's the mobility opportunity, not the challenge, the opportunity that it will bring to us. It can be solved, as Jacinta has pointed out, from the things that matter on accreditation, the discussions we're having, that's all set up. The skids are greased for this to occur. And it can occur both ways. I think over the next few years, the challenge will be in Canada and Ontario to address these problems that were pointed out earlier today. And let's take them. Dr. Patry was talking about innovation and moving that agenda forward. Well, those are going to be the faculty, the companies that are the risk takers, the students, postdocs, visitors to this country, and our ability to innovate from that crucible. We have to build it. Countries like Australia, in Europe, even Ireland and countries in other parts of Europe, in Asia, have taken that challenge. Go forward even bigger. India and China got it. They're producing hundreds of thousands of engineers at different levels to bring their countries forward. This is about nation building. And engineers can't stay quietly in the background anymore. We have to bring it forward if we want to assure ultimately the quality of life that we take pride in and to solve the problems we have here. There is a bigger challenge. The deans always talk about this, and I think you can appreciate this, and some of you have children and have mixed success, perhaps, in getting them to come to an engineering school. It is that. We joke about it, but it is a serious problem. It's getting young men and women to get excited about engineering education. And what can we do to deal with that issue? I think that is going to remain the biggest challenge. I think the opportunities are there, though, in the following sense. Young men and women, more and more, want to make a difference. They also want to get good jobs and have impact. They get all of that. These are very sophisticated people. Young men and women now, as you know, this generation that we certainly deal with, have the parents really involved with them. Sometimes as a dean, I think too much, but they're involved with them. They are involved, and they give them guidance. They give them tremendous guidance, and that's important. That's an important factor. Their families making collective decisions. And the profession that we're selling is competing with other professions. Medicine is the big one. Many of the students that are interested in science want to go to the competitor, want to look at science programs, perhaps as a pre-med program, and the high-end students that we want to attract. It shouldn't be a tug of war. Many of you here are lawyers and doctors and understand this. It's not a tug of war. Boundaries are crossing. Even with the last talk that we heard about clinical engineers and clinicians, there is this all crossing over between medicine and engineering and other disciplines and business. So we don't want to discourage that. But what we want to do is have the innovative programs, which we are now developing and continue to develop, to bring in these young men and women and make engineering an appealing discipline. They will change after 5 years. We know what we're talking about. Many end up in business, they end up in law, they end up in other areas. Engineers move on. It's the flexibility. We don't have enough in Parliament. I don't know if that's a bad thing, but I'll leave it at that. Sorry. But the thing is, engineers are flexible in that. One thing we have to do, if we're going to have effective policy, I believe, getting back to my main point here, is just treat engineers as engineers wherever they come from. Make it easier for them to practice engineering in Canada so we don't talk to a cabbie and say, oh, I didn't know you were an engineer. Not that they worked on Nortel. I'm talking to ones who came from other countries. I met them. So that is not a good thing. That's not something to be proud of. We have to make sure that that occurs. There is one last challenge in education here. I was talking to Jacinta earlier, and Claude knows this. The deans have been talking, and the province of Ontario, I think, is moving in the right direction in this area. They are trying to facilitate what they call the pathways for students, certainly from the colleges, from the technology programs, to have an opportunity to move into engineering schools. At the same time, mixed in with that, we have international students with different credentials, as Jacinta has mentioned, that come here that want to get that Canadian engineering degree and want to move in that direction. It's important that we facilitate that. I think the government is trying to do that. The challenge, of course, that we're having sometimes with the government is they see as a course. That's not necessarily true. College physics is different than university physics, so we have to fix that. So this is addressable, but I think it's a step in the right direction. And if I can challenge the government, as I said, on the other high end, with PhDs, to put in the investments into the universities to facilitate the movement of high-quality international graduate students so that they can augment the space, we will be in a much better position. Finally, the previous group, I know Mike Carter is a good friend of mine. We've been talking about retirements. You know, heart surgeons are going to be retiring, and that worries me. I want to make sure he's available. But engineers are retiring, and we want to make sure that also engineering professors are retiring. I'm retiring sometimes I think about tomorrow, but we're retiring in the next few years. It's a huge glut that's going to be missing. Where are the faculty? Where's the next generation of faculty? We have to take these measures, which has been discussed today, to move it into a position so we take care of it from top to bottom. Quality of education to the students at the undergraduate, graduate level, and make sure that the pipeline of faculty is improved at that end, on the university side, and from the business side, and the most important, on the building of Canada, to have the necessary young men and women and people worldwide that choose and want to be in this country, take advantage of it, and set up a system to facilitate that meets the standards. Thank you very much.
I think we have time for some questions from the floor. Kim will tell me how many. 2? Okay. So the first 2 to the mics.
Who wants to go first? I'll go first. Good evening. Thank you very much for the engaging talks. I have a quick question with regards to modeling of our postgraduate system against other postgraduates from other countries. This morning, Dr. Petre showed a chart of different countries producing different PhD, the quantity of PhD students they're producing. And one of them was Germany. I had a friend, I only have a lowly master's. I'm the dumb one in my group. They all have PhDs. And one of my colleagues, he went to Germany to do his PhD. Reason being, his parents are German nationals, so he was grandfathered in as a German national. And his postgraduate education was actually paid for by the German government. So I was wondering, have we looked at other countries' educational systems to see how viable it is to do that type of thing to attract our own postgraduates?
If you're, I mean, are you referring to the cost to the students or to the system in general?
Both, actually,
both?
because
Okay.
it's sort of prohibitive. Like for me, if I wanted to go back and do my PhD, it's a huge economic cost for me.
Yeah, yeah. I mean, on the economic front, in terms of the cost, I mean, different countries have different strategies with regard to post-secondary education. I mean, in some countries, post-secondary education is entirely free. It's 100% covered by the government. It's not the case in Canada. And in fact, if you look at how it varies across the country, you would find that Ontario is at the low end of the spectrum in terms of the amount of money that the provincial government provides universities on a per-student basis. And that applies as well to the undergraduate and to the graduate level. So there's obviously there's a political decision here to be made as to how much, what level of support the governments are willing to provide to support university education at the undergraduate and graduate level. In terms of the models, I believe that the models both for undergraduate education and graduate educations are continuously changing. They're continuously evolving to adapt to new realities. At the graduate level, now you have short programs that are meant to address professional development, continuing education needs. You have the standard master's and doctoral degrees that are meant to prepare people to enter careers that have a strong research component, whether it's in academia or industry. As far as I'm concerned, I believe that the system that we have in Canada compares extremely well in terms of the structure of our university program at the undergraduate and graduate level, compares very favorably with what exists in other parts of the world. But that doesn't mean that there's no room for improvements, and that's something that each of us we're doing on a continuous basis, basically to adapt ourselves to the needs that are coming from us, from the students, but also from the profession and from employers.